I've given you lots of information. That's probably longer than I wanted to talk about this, but there's a couple of questions here that you have to think about. The one last thing is, what happens if this is called, wherever my title is here, this is called growth and decay. We need to talk about decay. Decay is just the mathematical word for if it's going down, right? I will draw for you the Pringles can here. Here's the Pringles can. And here's the additional bonus 25%. Now, 25% more. So you would, and if you were going to repeatedly do this, every year they added on 25%, every year they would times 1.25. I can't tell you how, it seems like it should be an easy concept. If you add 25% on, you have 125%, and you can get to your answer, the total you have at the end, you can get to it easily by multiplying by 125%. It's tougher to really internalize that than you think, especially when you do something like this, which doesn't make much sense with the Pringles can, but now 25% less, right? If it's gone down by 25%, this went up by 25%. If it goes down by 25%, what percent is left? 75% is left. You need to use 75% in your function. If something says you're losing 10% per year, if it's the population of a town going down, you're losing 10% per year. When you set up your function, let's say you started with 1,000 people, you don't put in 10%. You don't put 0.10. You don't put in negative 0.10. You don't put in negative 10. You put in what's left. This is what you have left. To get the final answer, you would have to put, no, I changed my number here, but you have to put in 90%. If 10% are leaving, you put 90% there. That's what's going to be your model function to the x. Okay, for decay. The number you put in there, like if you compare it to what you know about, what you know from grade 10, something increasing or decreasing with linear functions is positive slope, negative slope, right? For exponential functions, something going up exponentially, right? B to the power of x, b is greater than 1, it goes up. If it goes down from there exponentially, b is less than 1. All right, we've seen this before, but this is in terms of what we know now, right? I'm going to make this graph into what we just had, which was $1,000 or people or whatever, 1,000 bacteria, 1,000 somethings, right? That's changing exponentially. What would this represent? What growth rate is that? 8%, right? You have to put in 108 because 1 is for the original amount. If I just put in 8%, I'd only have the new part, right? Just the yellow part on the Pringles can. If I want to make this go down at 8%, I would have to do 92, right? It's going to go down. The decrease exponentially is this number's less than 1. Increasing is that. If you made it exactly 1, that's no change. That's 0% growth. It's flat, right? But you have to put in 100% there because every year you have 100% of what you had the year before. Incidentally, if something was doubling, what if our Pringles can, if they said now, twice as much? They wouldn't use a percentage then because they assume people are dumb and that they don't understand percentages or anything. If they said, if it was if the red can, if they said now 2 times as much, double, it's this big, right? The yellow part's the same size as the red. What percentage would it be though? It would be like, it would say 100% bonus, but the number you'd have to put in your function is 200%, right? For the original part and the new part. For things like that, it's probably easier just to put double. It's doubling, right? Put a 2 in. Doubling is growing really fast. No one is ever going to give you that kind of interest because look at how fast it goes up here. Doubling goes up like this, right? After what, like this scale is 2 here. 1 is right here. You start with 1,000, you have 2,000 after 1 year, right? There's doubling basically. And then after another year, you have 4,000, then 8,000, then 16,000, right? Doubling is unless you go to a loan shark or something, they'll charge you that. I don't know. This is incidentally how, bacteria grow pretty fast, right? Bacteria double later on in here we're going to do something more complicated like bacteria growing, but the catch to this is it says this thing doubles every 5 hours. It doesn't double every hour. If it doubled every hour, it'd be nice. You could just say 850, 200% double to the x. But it doubles every 5 hours. You got to do something to the exponent before you set up this function. We'll get to that later. I think it's better that you start on this first before getting any further and do these first couple of things. Okay? I don't care what symbols you use. You can use, like some people say a times b to the x. You know how they told you in grade 10, oh, this is what it looks like all the time, mx plus b. Don't get so attached to one form that you freak out if somebody says something else. You want to freak grade 11s out, or grade 10s, I guess. Well, no, when they're coming into grade 11, you say, and you all learned about straight lines, right? Ax plus b. We didn't learn ax plus b. I don't remember that. We never learned that. Oh, you mean Emma? Oh, yeah. Oh, I understand now. I get it. Right? Don't get so attached to. You got to look at the structure, right? What they should be seeing is something times x plus something. So you should be seeing something to the power of x times another thing. Because then if somebody says, well, the population is represented as p equals p0 times r to the t, you don't say, oh, teacher never told us about p0 and r to the t. We only learned about, it doesn't matter, it's the same thing, right? It's some number times a rate to the power of time. You have to look at the structure, not the actual variables, right? This kind of makes sense for notation because, I don't know if you know in physics when you use a zero down there, what does that represent? Like p0 means whatever p represents, but when the time is 0, right? P at 0. Anyways, can you try those first two questions? It says write a model function that's going to have a y and an x or a p and a t or a whatever you're using, an a and a whatever symbols you want to use. Try the one on the next page where it says the school's going down. Think about that. Always longer than I wanted to talk, but that's okay.